All right. So we are going to sketch the graphs of these, and the only new information we know is its end behavior. So what do I know? This is a positive x cubed graph, and it's going to act like a line, and its end behavior is going to look like this. So that's a starting point. Now, one of the key graphing strategies that is the first thing you're taught when you graph, and it's the first thing you forget, but is a thing that you should be able to use no matter what kind of graph you want to graph, is you can always make a table of values. And so what does that table of values say? Well, here's x, here's y, or f of x. Put in a value. Tell me a number. 1. So if I plug in 1 for x, what's y going to be? 1 minus 3 would be negative 2. Okay? Tell me another number. 2. If I plug in 2, I'm going to get 8 minus 12, negative 4. 3. This will be 27 minus 27, which will be 0. 4. Plug in 4. We're going to get 64 minus 48, which is 16. So what we're doing is we're picking an x value, and we're substituting that x value, plugging it in for x. And then doing the mental math. 4 cubed is 64, minus 3 times 4 squared, which is 48. 64 minus 48 is 16. And if we kept going higher, we would get more numbers. Now, we didn't have to do just positive numbers. We could also include 0 is a good one to include because it's easy to calculate. Negative 1 would be a good one to include some negatives. And negative 1 cubed is negative 1 minus 3 times negative 1 squared be negative 4. And let's just do one more point. Negative 2 will be negative 8 minus 12, negative 20. So now that we have a bunch of points, we could plot them. So we're going to go up to 4. So I'm going to go 1, 2, 3, 4. 1, 2, 3, negative 1, negative 2, negative 3. 1, 2, 3, 4. I'm going to use that as my scale along my x-axis because that seems to match with what we did. Now on my y-axis, I'm not going to go by ones by the same space because we're going all the way down to minus 20. You see that that's our smallest number? Are you okay with going by 5s? Negative 5, negative 10, negative 15, negative 20. 5, 10, 15, 20. And we can plot our points. We have the point 3, 0. We have the point 0, 0. We have the point 1, negative 2. 2, negative 4. 4, 16. Negative 1, negative 4. Negative 2, negative 20. Do you get an idea what the graph is going to look like? We know that it's supposed to do this as end behavior like our line. Does it look like it's going to do that if we play a little bit of connect the dots? Okay, and I connected the dots. I connected the dots with a smooth curve. This isn't a perfect graph. We don't know that the dots couldn't have been connected like this. Could have been higher there. We don't know that. Okay? But based on what we had, either that purple graph or that black graph would be fine and would be a right answer. So as of now, we have a strategy that says, what can I do with this graph? I can graph a bunch of points, I know the end behavior, and then I can show my graph what it looks like based on those points. The more points I have, the more accurate my graph is going to be. Later on, we're going to use our strategies of factoring and x-intercepts to get a more accurate graph and a more accurate measurement of how it looks. It still won't be a perfect graph. You won't be able to graph this really nice and perfectly until you take calculus next year. And calculus will provide us with a technique to really graph it well. So B is more of the same, of just making a table of values and graphing. So we're going to skip it and say the questions to do for practice are 5, 6, and 8.